This video is a guide to calculating the efficiency of an energy transfer, where instead of being given the total energy in and the useful energy out, you will be given the total power in and the useful power out. So let's take a look at the equation we had last time. We had that efficiency is equal to the useful energy out divided by the total energy in. But since power is equal to energy per unit time, we can actually have a similar equation where we simply replace the word energy for the word power, and we have that efficiency is equal to useful power out divided by total power in. Remembering that efficiency as a number is simply useful power out divided by total power in, and this will give you a number less than 1. Meanwhile, efficiency as a percentage, whatever answer we get for useful power out divided by total power in, we multiply that by 100%, and that will give us the percentage efficiency. So let's start with an example. It's very similar to an example we had previously. A kettle is supplied with a power of 2000 watts. The useful energy transferred to internal energy store of the water is 1800 watts. Calculate the efficiency of the kettle. So we write down our equation, efficiency equals useful power out divided by total power in. We simply replace the numbers. The useful power out in this case is 1800. The total power in is 2000 watts, and that gives us an answer of 0.9. We then simply multiply that by 100% in order to give us the percentage. This kettle is 90% efficient. Next, a car has a total power input of 45,000 watts. 40,000 watts are wasted as energy is transferred uselessly to the internal energy store of the engine. Calculate the efficiency of the car. Now this time we're given the wasted power. We aren't given the useful power out. So to work out the useful power out, we take the total power in and subtract the wasted power. That gives us an answer of 5,000 watts. So we write down our equation again. We put 5,000 watts divided by 45,000 watts, and that gives us an answer of 0.11. And if we want it as a percentage, we simply times it by 100%, giving us an 11% efficiency. Finally, a human's muscles are around 25% efficient. A man pushes a trolley using 200 watts. Calculate the useful power supplied to the kinetic energy store. That means that every second more energy would be put into the kinetic energy store, and we'll look at just how much more. So 25% we know is 0.25 for efficiency. We want to make that conversion first before we then plug it into our equation. So we now have that 0.25 equals useful power out divided by 200. We're going to do our inverse operations here. Since we've got divided by 200, we're going to multiply by 200 on both sides of the equation. That will get rid of the 200 on the right hand side, leaving us with 0.25 times 200 equals useful power out. So the useful power out is 50 watts. That means every second the man is adding 50 joules of energy into the kinetic energy store.